Hello viewers, I'm Kausalya. Today we are going to solve problems related with RL transients. The problem is, in the series RL circuit of figure, the applied voltage is given by this expression. Find the resulting current and the initial rate of change of current. Right, so this is the given circuit diagram, and this diagram has a resistor and an inductor, and there is a voltage source, and I is the current that flows through this circuit. Right, so again, the basic thing is here we have to apply our KVL. So when you apply KVL, the thing is sum of voltage rise is equal to sum of voltage drop. Right. So the voltage drop is caused by these two elements and voltage rise is given by this source part. Therefore, the voltage drop across resistor is given by I into R. Right. So here I is the current that flows through this part. So I into 50. Similarly, voltage drop across the inductor is given by 0.5 into di by dt, that is L into di by dt, which is equal to the voltage rise, that is 100 into e to the power minus 50t. Okay, this is given in the problem. So the next step is we are going to take Laplace transformation. So once you take Laplace transformation, you see I becomes I of s and di by dt becomes s into I of s, and e to the power minus 50t becomes 1 divided by s plus 50. Right, since here we are having 100, it becomes 100 by s plus 50. Then the next step is we are going to take I of s commonly outside, right? So the remaining terms will be 50 plus 0.5 s. Therefore, when you write expression for I of s, it is given by 100 by s plus 50 into 50 plus 0.5 s. Right. So we already need the denominator terms as s plus some numbers. Right. But here to s, that is with s, we are having another 0.5. Therefore, we are going to divide this expression by 0.5. So when you take 0.5 outside, you see our expression gets modified as s plus 50 by 0.5. Right. Again, when you simplify, that is 100 by 0.5 becomes 200, right? And this term remains as such, and here s plus 50 by 0.5 becomes 100, right? So the next thing is we are going to take partial fraction. So when you apply partial fraction, you see here denominator we are having two terms, therefore we have to split this expression into two individual terms, right? Then the next step is we have to take LCM. Once LCM was taken, you see both the denominator terms are same, so they cancel each other. So after cancelling the denominator, we are having an expression like this. So our aim is to calculate the values of A and B, right? So to calculate the value of B, you see, we are substituting the value of S as minus 100. So minus 100 plus 100 will make the term A as 0, right? And in the remaining terms, when you substitute the value of S as minus 100, here it looks like this. Therefore, 200 is equal to minus 50b. Therefore, the value of b is minus 4, right? The next step is we have to find the value of a. To find the value of a, we have to make the b term 0. So, in order to make the b term 0, you see here we are already having plus 50. So, here we have to substitute minus 50, right? So, substitute s as minus 50. The b term becomes 0 and the value of a becomes 4 here. Right. Now we have calculated the values of A and B. Therefore, just substitute these values. So when you substitute these values in equation, you see here, this is our I of S. So our aim is to find the current, right? So everything should be in forms of T. Therefore, we are taking inverse Laplace transform. So I of S becomes I of T, and here this 4, S plus 50 becomes e to the power minus 50t. Similarly, here s plus 100 becomes e to the power minus 100t, right? So this is the current. Then the next thing is we have to calculate the initial rate of change of current. So rate of change of current, the word rate of change, that denotes we have to differentiate this current with respect to time. Right. So when you differentiate this expression with respect to time, you see here this 4 remains as such, right? And e to the power minus 50, when you differentiate this term, minus 50 comes here and this term remains here as such. And again here minus 4, and when you differentiate this part, e to the power minus 100t, so this becomes minus 100 into e to the power minus 100t, right? So once you multiply, you see here our expression becomes minus 200 and here this becomes plus 400, right? So now in this case we have to substitute the value of t as 0 because we are going to calculate the initial rate of change of current. So when you substitute the value of t as 0, what happens? You see here e to the power 0 becomes 1. Similarly here e to the power 100 into 0 becomes 1. Therefore 4 into minus 50 becomes minus 200 and here minus 4 into minus 100 becomes plus 400. Therefore here the final answer is 200 amps per second. Right. So here comes the end of this problem. We will move with the next one. Now we proceed with our next problem. The problem is find how long it takes after the key is closed before the total current from the supply reaches 25 milliamps. When V is equal to 10 volt, R1 is equal to 500 ohm, R2 is equal to 700 ohm and C is equal to 100 microfarad. So here you see this is the given circuit diagram, right? We need to calculate the how long it takes, that is we need to calculate the time, right, before the current reaches, that is when the total current from the supply reaches 25 amps, right? What is the time at which the total current from the supply reaches this 25 milliamps, right? So here in this case the value of supply voltage is given, R1, R2 and C, everything is given, right? So when you look at the circuit diagram, you see we are assuming let I1 is the current that flows through this R1 and I2 is the current that flows through this R2 and C. Right. So here the value of voltage is, it is nothing but 10 volt. So when the switch T is closed, you see this voltage will be impressed across this R1, right? Because this voltage is connected in parallel with this resistor R1. Therefore, it is easy for us to calculate the value of I1, right? So I1 is given by V by R1. So here I1 is V by R1, V is 10 and R1 is 500. So just substitute the values and the value of I1 is 20 milliamps, right? So again when you look back at the problem, you see the total current from the supply is 25 milliamps, right? That is here we are having a total current of 25 milliamps and the value of I1 is 20 milliamps. Therefore then what about the value of I2? This will be equal to 5 milliamps, right? So this is what we are doing here, right? You see the total current is 25 milliamps, I1 is 20, therefore I2 is 25 minus 20 which is 5 milliamps, right? Now the next thing is the current flowing through an RC network is given by I2 is equal to capital I2 into e to the power minus t by RC. So here in the place of R we are having R2, therefore R2C, right? So what is I2? I2 is nothing but V by R2, that is steady state current. So the value of V is, you see, again look at this circuit. So here the value of V is 10, right? So what is the value of R2? It is 700. Therefore just substitute the values. So here the value of I2 is 5 into 10 to the power minus 3. The value of V is 10 and R2 is 700 e power minus t by R2 into C. Therefore, the value of R2 is 700 and C is 100 microfarad, right? So, just substitute the values. So, here once you solve, you see here the 0 cancel each other and here we are having 1 by 70, right? I am moving this 70 to the left hand side, therefore, it occupies the numerator part, right? And once you solve, here we are having the answer like this. So the next step is you have to take ln on both sides. So when you take ln on both sides and you solve, finally the value of t is calculated as 0.0735 seconds, right? Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.